In this section, we're going to look at measures of center. Now that we know how to display some data and organize our data, we're going to try to summarize our data with the idea of what the center of the data set is. So we're going to look at three different types of center: mean, median, and mode. So again, given a bunch of data, we want to summarize the data in some meaningful way. And we're going to try to do this with just a number. And this number is going to try to tell us what the center of the data is. And center is in quotation marks there because it's not really clear what the actual center should be. And again, we're going to have three different ways to sort of show it. So the mean, which we often think of as the center, a more common kind of way of thinking about it, is the average of all of the data. The median is the middle value of all the data. And the mode is the data point that's going to appear the most in our data set. So when we're looking at these three different types of center, each measure of center has its own advantages and disadvantages, and there's not one correct way to say what the center of the data set is. In fact, if you have a big data set, what's often most useful is to use all three versions of the center to give some better understanding of what the center is and what's going on. Note that in the next video, we're going to look at another way to summarize the data, and that is the spread of the data. And those two together give us a lot of information about what's going on. So first, let's focus on the mean. To find the mean, denoted X bar, that bar didn't show up, X bar, we will add up all the data points and divide by the number of data points. So note that we have this notation right here, this sum of X. This is our summation symbol. The key word there is sum. This is the Greek letter sigma. It's a capital sigma, and the S for sum in the Greek letter. That means we're going to add all of our points together. Then we're going to divide by the number of data points. That is our average X bar. So a quick example. In heights in inches of a classroom of 10 people were found. I should say the heights in inches of a classroom of 10 people were found. What is the average height in the classroom? So we're given 10 different people, 10 different heights in inches. We want to find the average. So our average X bar is going to be adding all of these together. 64 plus 62 plus 70 plus 55 plus 57 plus 55 plus 69 plus 66 plus 68 plus 74. We're dividing by how many we have, which is 10. This gives us 640 divided by 10, which is 64 inches is our average. Note that the average should make sense, right? It should lie in between the biggest value and the smallest value, and it should kind of make sense of the data that we're given. Let's look at some more complex examples with finding the mean. So in 2013, Tony Kanaan won the Indianapolis 500-mile race. In doing so, Kanaan set a track record finishing in 2 hours, 40 minutes, and 3.1481 seconds. His recent finishes in the Indy 500 are given in the table below. So we have 4 different years, including his winning year in 2013, and the different times in hours, minutes, and seconds. We want to find the mean finishing time in Tony Kanaan's given Indy 500 outings. So why this is more difficult is because we don't have a standard unit that we're sort of looking at. We have hours, minutes, seconds. We can't just add those together. There's not a way that we can do that. So we're going to have to translate all the times into one unit. We could do this with hours or minutes or seconds. We'll choose minutes here for no particular reason. So if we look at maybe one of these, let's look at the 3 hours, 6 minutes, 36.6062 seconds. The 3 hours we can write as 3 times 60, or 180 minutes. The 6 minutes is already there. That's already going to be 6 minutes. And the 36.602 seconds we can divide by 60, sorry. And that will give us how many minutes we have. It's about 0.610 minutes. So if we add all of these together, we get 186.610 minutes, and that's what we're putting in our time. And we could do that with all 4 of our times and translate them all to just minutes. And once we do that, now we can actually add these together in a meaningful way and get an average. So our average, we'll call it again X bar, is going to be 186.610 plus 176.195 plus 178.854 plus 160.57 divided by how many times we have, which is 4, which gives us about 175.429 minutes. And we could translate this back into our hours, minutes, seconds format. That would give us 2 hours, 55 minutes, 25.74 seconds. And the way that we could do this, we could think about this as 120 minutes plus another 55 minutes plus 429 minutes, 120 because that's 2 hours, the 55, and then 0.429 minutes, if we multiply by 60, will give us 25.74. But this 175 is a reasonable answer here. All right, then let's find the average speed in miles per hour of Tony Kanaan's 2013 Indy 500 victory. So that is, we're just looking at now the 240.03.4181. In fact, we're going to look at this 160.57 minutes. And we know that this is the time in minutes. And we know that the distance that we are traveling here is 500 miles. The rate is going to be distance over time, like miles per hour. We just need to translate our 160.57 minutes into hours. So we can do that by saying 160.57 divided by 60 will give us 2.676 hours. So the rate here is going to be 500 miles over 2.676 hours for about 187.43 miles per hour. That is our average speed in that race. All right, let's look at another example. This time we're looking at grouped data, just like we looked at with the frequency diagram or frequency distribution. So here is the age distribution of workers who received minimum wage, that's $7.25 an hour, in 2012. Find the mean age of a worker receiving minimum wage. So the issue here is that we don't know the exact ages of the people. We only know a range, and that's a little bit more difficult to deal with. So because we only know a range, we will estimate the age of the people using the midpoint of each range. So let's add another little column here. This will be our midpoint. So the midpoint of each range is going to be the, in between 15 and 25 is going to be 20, 30 for the next, 40 for the third, 50, and 60. So instead of knowing the exact ages in between 15 and 25 of the 861,000 people, we're just going to estimate that they're all about 20 years of age and hope that it kind of balances out. With more information and more detail, we could get a better estimate. So what we could do here, we have 861,000 people age 20, 243,000 people age 30, 154,000 age 40, on and on. We don't have to go 20 plus 20 plus 20, 861,000 times, or just 861 times. And then do 30 plus 30 plus 30, 243 times. This is what it would be to add up all the numbers. Do the same for 40, 154 times. 50, 164 times, and 60, 100 times. That'd be a lot of work. Instead, we can just use multiplication. We could say this is going to be 861 copies of 20 plus 243 copies of 30 plus 154 copies of 40 plus 164 copies of 50 plus 100 copies of 60, all over the total amount of people that we have, which is going to be 861 plus 243 plus 154 plus 164 plus 100. That's adding up the number of workers in thousands, and both the top and the bottom are in thousands. The bottom here, this is going to be our average. The bottom here is going to be 1522. And if we add up the top, we're going to get 44,870 divided by the 1522 will give us about 29.48. This is the average age. And it's about that. Note that we don't actually have the exact value because we had to guess the number of ages with the midpoint. If our range of ages were smaller and smaller, this estimate would actually get better. In fact, that's actually a huge part of what calculus is all about, doing that kind of estimation. In a similar sort of problem, let's do another kind of idea of mean. 10 college students were comparing their wages earned at part-time jobs. 9 earned $10 per hour, which seems fairly reasonable, and 1 student earned $200 per hour, and let's not ask about what that student did. They did something to make that money. Find the mean wage of the 10 students. So once again, we could do 10 plus 10 plus all the way 10, do this 9 times, plus 200 and divide by 10 people. Or we could just say this is going to be 9 copies of 10 plus the 200 divided by 10, which is 290 divided by 10, or $29 per hour. There is our average. And let's think about this as our average. It should kind of make sense a little bit. The $200 weighs a whole lot when we think about the average. But in this case, the $200 per hour is an outlier. It is much different than the rest of the data. And this is skewing the mean. It's pulling the mean toward that value. And because of this, the mean is not really the best way to look at the center here. In general, when an outlier is present, the median is the better measure of center. And let's talk about why that's the case. So let's find the median in the above example. So the median here is going to be the middle value. So let's list out all these values. There are 9 tens and a 200. To look at the middle values, kind of just cross out the end values one at a time until we get to the center. And here we're left with actually 2 values in the center, so we're going to take the average between them, which is just going to be 10. So our mean is 29, our median is 10. Let's talk about the positives and negatives of both of those. To say that the average wage here is $29 is to give this impression that most people earn about $29 an hour, when in fact that's just not the case. Almost everybody earns $10 an hour, with one person earning a lot more. So that $29 is deceptive in what it's actually saying. The median says that, it's $10. That's going to be what most people make. That's kind of the center. And that definitely makes more sense. It doesn't give any indication about that one student who earned $200 per hour, but that's the idea of an outlier. It's something that's just different from the rest of the data. So now let's talk about median in a little more detail. Find the median of the following 2 sets of data. So first, what we have to do is organize the data from least to greatest. So we have a 2, 2, 3, 6, 8, an 11, and a 12. And again, what we're going to do is we're going to cancel out the last and first values until we end with one middle value. And this is our median. So if we have an odd number, if n is odd, then the median is just the middle value. In the next example, which we had before, where n is even, so again, let's arrange this from least to greatest. 2, 2, 3, 6, 8, 8, 11, 12. We added an extra 8 here. When we look at the median, we're kind of canceling out the top and the bottom, the first and the last in order, but then we're left with 2. So we take the middle of these 2 values. That's the average of them. 6 plus 8 divided by 2, which is 7. So if n is even, the median is the average of the 2 middle values. So one more thing to say about the median. Note that this was the fourth value that we picked. And note that in this case, n was 7. So the median, when n is odd, is going to be the n plus first divided by 2, this value. So 7 plus 1 divided by 2 is 8, or sorry, 8 divided by 2 is 4. This is going to be the fourth value. The median, when n is even, note that here n is even and n is equal to 8. We do the n plus 1 divided by 2 again. Here we have the 4.5 value. It's kind of like in between. This is going to be in between the n minus 1 divided by 2 and n plus 1 divided by 2 value. Now, these formulas are totally not necessary if you only have a small amount of values, but it's very easy to do an example where we have a large amount of values, and there these become a lot more handy. All right, so here we go. The students in a classroom were asked how many siblings they each had. The frequency distribution is given below. Find the median number of siblings. So we have 2 plus 8 plus 5 plus 6. That's going to give us 21 responses. And yes, we could list all these responses out from least to greatest, right? We could do our 2 responses that are 0, our 8 responses that are 1, our 5 responses that are 2, our 6 responses that are 3, and we could find the median systematically by crossing a bunch of stuff out. We're left with a 2. Or instead, we could use this formula. There's 21 responses. That's odd. So the median is going to be the n plus first over 2 value. That's going to be 21 plus 1 divided by 2. That is 11th value. And the 11th value is going to occur in here because we had the 10 values before from 0 to 1. So here the median again is 2, and that's an easier way of kind of doing it. And again, if n was much bigger than 21, it might be the only way of doing it. So to clear up actually one little mistake I made, I said the median will be in between the n minus first and n plus first over 2 value. That was a little bit wrong. This should say between the n over 2 and n plus 2 over 2 values. That's n plus 1 over 2. All right. Lastly, let's think about the mode. The mode is maybe the easiest to sort of calculate, but it's useful in some circumstances. The mode is simply the value that appears the most. So in our first data set, we have 10 that shows up 3 times. So the mode here is 10. And it gives us an idea of what the biggest value is in the data, which tells us something about the data there. Let's look at the next example. Every value here has two values. So that means that there is no mode. There is no one common value. There's no more common value. They're all equal. So here the mode didn't give us any information except the fact that they're all kind of equal. And in the last example, we have 2 3s and 2 9s. So the mode, and there can be more than one, the modes are going to be 3 and 9. And note that this is called a bimodal distribution. Bi meaning two, modal meaning modes. So there's a two modes distribution, bimodal distribution. When you put it all together, mean, median, and mode give us an idea of the center of the data set, of the distribution, which is a way to summarize the data. In the next video, we're going to look at the spread of the data. How can we think about how far apart is the data from one and from the other, and combined, that will give us a good picture of the data set in general.